G'day team, welcome to another video. This is the one where it's all going to come together, everything that we've gone over in the last 3 videos. So this would be number 4. We've gone through how to read a contour map. We've gone through how to draw a topography based on the 2 kinds of contour maps you might get, like if it's manual or automatic. And then we've gone through how to actually go through the cut and the fill and work out where to place the property. So this last part of the video is going to be how to model the 3D cut and fill that we calculate. So what we have here is this is a real house. We've got a contour survey, which we have been provided by a surveyor. So they've gone out on site and they have put together this topographical map or contour map, and they've now sent it to us. So we need to now work out where the pad level of the house needs to go. And a little spoiler here. So obviously I deleted everything before making this video, but yeah, so the pad's 23.1. So it's going to be this contour. So that's roughly kind of halfway through the house. It's not a particularly steep site, but I'll quickly go through and do everything that we've kind of learnt so far, and then we'll pick up where we left off. Okay, so just to recap what we've done, we drew the pad line around, we worked out our cut and fill line, then we worked out the extent of our cut and our fill based on how many contours they are away from our 0 level. We projected the edges of the pad lines out, and then we joined them all up. We were careful not to join them actually like at the pad line. You just join them a little bit off, and then we've put our cut and our fill, I call them like batter arrows, to show just visually that this is fill, this is cut, for example. So something that the eagle-eyed viewers may be wondering about is these 2 car parking spaces off to the side here. So technically what we've drawn is going to be having like some earthworks right in the middle of where you would be expecting to park some cars. So driveways and car parks and all of that kind of thing, they tend to be a bit kind of secondary to the house pad. So what we've drawn here is like of the highest importance to the actual structure and slab and footings and everything to do with the house. The extents of where the pad goes to in regards to driveways and car parks and all of that kind of thing, it's a bit kind of secondary importance. So what I generally show and have done for many, many years is just to do with the house. Often the driveway will, say if the driveway was here, the driveway would go out over this cut and fill or this this batter bank, and it's just not something that we've ever got any feedback from the builders about them needing to see any different. They just kind of just make it work with the driveways, unless it gets like really, really sketchy with really steep driveways. Generally what we're showing here is just to do with the house. You don't want to overcomplicate things. Just keep it simple, keep it easy. Easy to read plans are good plans. Like that's a fundamental thing. So this is great, but doesn't actually show us anything in here. So let's go up here, massing in site, topo surface, create from import, select import instance. I'm pretty sure just this warning down here is just saying topographical elements are not visible. So we've obviously got it hidden in the view. Select this, check none. And then what we want to be using is major contour 3D. You can check out which layer you want to use first by clicking on the survey, or the DWG, should I say. Click on query, and then click on any of these lines. And then it's going to tell you the layer / level that this is drawn in. But the thing to notice here is it says minor contour 2D. That tells me that if they've got a 2D one, they've probably got a 3D one, and you're almost always going to want to use the 3D layer, and they will have just hidden the 3D layer in the export. So, topo surface, create from import, select import instance, click on this, check none. Major contour 3D, minor contour 3D. Okay. Excellent. All right, so it's almost certainly hidden. But that's our topo surface right there. Let's phase this as existing for now, and then we'll have a look. So we can clearly notice that that is actually way too high, and that's not too bad. That's really not the end of the world. We know that our cut and fill, or our pad line, is the 23.1 meter contour. So if we go edit surface, we'll have a look here. So you click on this and you'll see that the elevation for this is 23.1. So it's 23.1 meters above what is considered 0 in this project. So Revit has a bunch of complicated ways of working out heights and levels of things. And yeah, different offices will have different setups. So all you need to do to fix this is incredibly simple. You need to go here, grab it, move it down 23,100. Go back to our site plan, edit surface, 0. Perfect. So what we've drawn as our 0 line is now at 0, which is fantastic. Now that we've got this topography, and that's the existing one, that's great. I don't want to touch it, don't want to move it. What I'm going to do is I'm going to go Control C, Control V, and then use the, what is it, like, aligned to same place, which I've got as a shortcut of VZ. So now we've got a new topo surface and an existing topo surface. So it's important to have both because, well, for two reasons. One, if you ever make a mistake with like modeling up the new construction one, you can just delete it and then duplicate the existing one again. And then two, once we've actually modeled our cut and our fill, we can use some phase filters to show an existing topography like on the elevations so that we know where the natural ground line is. I also like to go phase demolished new construction, just so that when we're in the new construction phase, we've only got the one topography to deal with. Right. So this is the part that you're, I'm sure, all been waiting for, and hopefully I haven't made you wait for too long, but like I said with these things, it's always good to thoroughly understand what you're doing. How do we get this topography to match or to suit what we've drawn here to reflect that in elevations, 3Ds, everything else? What you're going to do is you're actually going to split this topography. So we're going to go massing and site, split surface, and then we're going to select our main topography. What we're going to do here is we're going to tab select to select the external perimeter of our cut and our fill boundary, and then we go OK. So the fact that that didn't work makes me think that, yeah, there we go. So we're not quite joining perfectly. Good. So if you tab select it and it doesn't all go to all select at the one time, it's probably not forming a loop, but we're forming a loop now. That's okay. All right, so this is good. Let's have a look at this in 3D. That's the extent of our cut and our fill, but we still don't have the pad reflected at all. So we need to change that. Go back into our site plan, select this cut and fill topography and we're going to split it again. Sorry, you don't need to do that. You can just go split surface and then click on this one in the middle. There's an unnecessary step there. All right, and now what we're going to do is we're going to select the pad perimeter. And then go, okay. So this is all good now. This is really starting to come together, but it's still not quite at the right level. How do we fix that? What we need to do so I'm just going to turn on select element by face here. So I can select this. All right, let's go edit surface. See how we've got a bunch of topographical points here. These all, because this is the pad, these all need to be 0. So let's have a look in 3D now. Okay, starting to come together. That's a pad, but there's nothing really connecting natural ground and the pad. So cut and the fill needs to be modeled as well. Let's select this topography. So this is the extent of our cut and our fill. And then we'll go edit surface again. I want you to select everything here, go up to filter, check none, and then all of these interior points we're going to delete. Okay, now that we've got rid of all of those, so this is kind of the magic part. All of these exterior points, they're all going to stay exactly as they are because that's where this cut and this fill meets natural ground. So this line needs to be natural ground. This interior line, however, this all needs to be 0 or pad. So go around and select all of these using holding down the control key to select multiple things at once. And then if you want to deselect anything, you use the shift key. So I'm fairly confident I've got everything there. Now we're going to change the elevation of these to 0. Go OK. That's it. Very, very simply put together. It really doesn't take that much time, and it's very effective. So also, I'll just notice this as well. Like this is just a more of a in this job than in general thing, but we've got this like a little pile of fill out here, which the surveyor actually picked up. But like realistically, when they're going to be building this house, they're just going to wipe that, and it's just going to be flat. But it's fine. So now that we've actually modeled this, let's have a look at a front elevation. Okay, so you've got a bit of an old school method of connecting the cut and the fill here, right? So this was just a detail line between the two, between the points where, so this is natural ground, this external topography, and then you can see there's another topography here, which is your cut and the fill, and then this is your pad. So in the elevation between natural ground and natural ground, you usually want to show a dashed line. So this is what I was saying before about, if we go show all, you can see that, sorry, so changing the phase filter to show all means that this topography, so our existing topography, which is demolished, has been able to show up. So you can use that to then just trace with a detail line, which, you know, for often's sake is just about as neat as showing the actual topography, or if it's a bit more of like an extreme. So this is probably a bit of a better example. So you can see the existing topography going through here. So you would need to get into overriding the graphics of the topography, because the existing topography at the moment is not showing up as transparent. So it's not showing the brickwork underneath the natural or existing natural ground down to the pad level. But you know, that's all graphics overrides, filters and stuff. So you guys can figure that out for yourselves. It's really not that complicated, but that's it. So this part is probably the part of this video is probably the easiest and quickest part of the whole thing, rather than calculating and drawing the cut and the fill boundaries. But yeah, if you're able to apply all of what we've learned in those 4 videos, you should be well on your way to being able to confidently receive a topographical map, put the house at what you believe should be a reasonable level, and then model after designing your cut and your fill extents. So that's that's a very important skill to have, because it's something that you're going to need to do if you're working on residential properties. This is quite an easy example, believe it or not. So there's not much actual cut and fill here. It's quite a flat-ish site. You get to some other examples where the house is much closer to the boundary. You've got much steeper gradients involved, so you have to, we drew these at 1 in 4. You can go from 1 in 4, 3, 2, 1. Once it gets past 1 in 1, you need to start looking at retaining walls. I'll probably put together a video about how to draw retaining walls and retaining wall elevations, because they're pretty important to know. But yeah, for just the purpose of topography, I think this is pretty much covered it. So yeah, if you need any more content, let me know. As always, thank you for watching, and talk to you all soon. Cheers.